Hello, my name is Darren Steele, and I'm teaching finite math online based out of the Franklin campus. I will be demonstrating systems of equations 2 by 2, starting with this document. Okay, it should be attached it should be in the Ivy Learn modules for this class that I've added. There are two primary methods, algebraic methods, used to solve systems of equations. I'm going to be talking about agenda, 2 by 2 systems. Okay? The agenda is going to be substitution and elimination. I am here right now. I will move I will move that when I go to elimination. There seems to be a glare in here. I'm going to go over. Okay, looks like that takes care of it. So here goes. So you probably have done something similar to this in courses beneath this level. This is example 0. You might be told that you got something like 3x plus 7y equals 17. And you might be told that one of the values equals a certain value. Okay? In which case you would have simply plugged this value in for the other variable. So 3 times 2 plus, 3x plus 7 times 2 equals 17. Okay? Simplify that. You got 3x plus 14 equals 17. Subtract your 14. Subtract your 14. 3x is 3. If you divide off the 3, 3x divided by 3 equals 3 divided by 3. So x equals 1. And y still equals 2. So in ordered pair notation, the x would come first, the y would come second. Okay? Now, that's different from a problem like this one, where you may not have had this before you were introduced to intermediate or a late beginning algebra class. This is going to be 3x plus 7y equals 17, and this time y equals 2x. Okay? That's the same general idea. You're going to replace the y with 7. You're going to replace the y with 2x. Okay? And that's going to give you 3x plus 14x equals 17. Okay? Which gives us 17x. Okay? Divide off the 17, divide off the 17, x equals 1. And y equals 2 times 1, which is 2. Okay? So x equals 1, y equals 2. 1, 2. Okay? All right. Let's see. I'll do example 2 over here. Okay, I think there's probably room. Okay, example 2 is on the back of the first sheet, and you have 4x minus 3y equals negative 19, and y equals 5x minus 1. Okay? Well, what you would do is you would replace y with a 5x minus 1. So you'd have 4x minus 3, and you'd replace y with 5x minus 1. Okay? You would simplify that. 4x minus 3 times 5 is minus 15x, and then plus 3. Okay? 4x's take away 15x's is negative 11x's. subtract your 3, and negative 11x equals negative 22. Divide off the negative 11, divide off the negative 11, x equals positive 2. Okay? And y equals 5 times 2 minus 1. So, that is 10 minus 1, that's 9. So x equals 2, y equals 9. So you have word pair 2, 9. All right. Let me get examples 1 and 2 off the board. Example 3. Okay, example 3. Example 2 is over. I'm going to leave example. I'm going to do example 3 over here for comparison purposes. We have x minus 6y equals negative 32, and 3x plus 4y equals 14. Okay? Now, we don't have x equals or y equals. So what I would do is I would solve for one of the variables. If I'm dead set on solving this by substitution, I would find the variable that's easiest to solve for. You're looking for a coefficient of 1. So the coefficient here is 1. You don't see it. Here's minus 6. Here's 3. This coefficient is 4. So since this has a coefficient of 1, I will solve x minus 6y equals negative 32 for x. So I would add 6y. Now it's going to look different than it's going to look on your paper. Okay? This is negative 32 plus 6y. You can change the order of addition. So we could put the 6y first, and then adding negative 32 is the same as subtracting it. Okay? Now, since this is the equation I solved for, it needs to go into the other. Plug into other equation. It needs, so this was the equation I solved. This is the equation I messed with. It needs to go into the other one. So we'll have 3 times 6y minus 32 plus 4y equals 14. Okay? So this will be 18y minus 96 plus 4y equals 14. Okay? These two combine, 18y's plus 4y's is 22y's. Minus 96 is 14. Okay? Add your 96. We end up with 22y equals 110. So this time, since we can't really normally divide by 22s in our head, I'm going to go ahead and actually show the division step. So y would equal 110 divided by 22 is 5. Okay? So we have y equals 5. I need x. Okay? So I have y equals 5. Now I need x. Okay? I'd use this. X equals 6y minus 32. So x equals 6 times 5 minus 32. So x equals 30 minus 32, which is negative 2. So x equals negative 2, y equals 5, negative 2, 5. Okay? Let me get this off the board. So now I move on to elimination. So I am here. Okay? So example 1 is 2x minus 3y equals negative 20. And this is 3x plus 5y equals 27. I will now proceed to also set up example 2, which is 2x minus 3y equals negative 20. And 3x plus 5y equals 27. You will probably notice that this is the same problem, but I'm going to do it differently. I choose to eliminate x. Let's see, is that what I did? Actually, yes, I chose to eliminate x. This time, over here, I chose to eliminate y. Okay? So, what's going to happen here is I need these two. If I choose to eliminate x, I need to be able to add these up so that they cancel. Okay? So I need them to be the same number but opposite signs. So the lowest number, the 2 and 3 divide evenly, is 6. So I need 6x and negative 6x in either order. Okay, you guys can see that on the paper. Okay, so I need 6x and negative 6x, or negative 6x and 6x in either order. Okay, I think I'm going to do this one. This is my choice. Okay, I'm going to choose that one because we're used to saying negative seconds we're used to saying subtraction second ever since we've come up in first grade. Okay, so I would need to multiply this by 3 to get 6x out of it. I'd multiply this by negative 2 to get minus 6 out of it. Okay, so 2x minus 3y equals negative 20, and 3x plus 5y equals 27. Okay, this is going to be 6x minus 9y equals negative 60. This is going to be negative 6x minus 10y equals negative 54. And we're going to add these two equations, and as expected, that's nothing. This cancels. The x's cancel, leaving me negative 19y equals negative 114. Okay? Very quickly, I'm going to grab my calculator. So I will take negative 19y, divide off the negative 19. And y equals negative 14 divided by negative 19, 6. Okay? Now, what I can do is I can plug this 6 into this equation or this equation. It really doesn't matter. Okay? So I can plug this into either equation. So let me grab a coin. And I'll flip a coin. Okay? I'm going to flip a coin. If I get heads, I'm going to use this equation. If I get tails, I'm going to use this equation. Okay? So it really doesn't matter which equation I plug in. Okay, it's heads. So I'll plug it into this equation. On my paper, I plugged it into this equation. So to show you that it can go into either, I am going to go ahead and use the other one. plug into either equation. Okay, so I flipped the coin, I chose it, I got this one. So that's going to be 2x minus 3y equals negative 20. 2x minus 3 times 6 equals negative 20. Okay. 2x minus 18 equals negative 20. Add your 18. And 2x equals 2. Negative 2, sorry. Divide off the 2. Divide off the 2. You end up with x equals negative 1. So x equals negative 1. Y equals 6. So negative 1, 6. In order pair notation. Now, in this case, I chose to eliminate y. So I need 15x and negative 15x, or negative 15x and plus 15x. If you notice, this is already negative and positive, so I'll go with this one. Negative, positive, negative, positive. Okay? Choice. That's my choice. Okay? So to get this to be negative 15x, I would only need to multiply this by 5. So 2x minus 3y equals negative 20. If I want this to be 15y, I would need, if I want this to be 15, and these should be y's, I'm sorry. Okay? If I want these to be 50, if I want this to become 15y, I need to multiply that by 3. Okay, so that's going to be 3x plus 5y equals 27. Okay? Now we'll move this, and now I'll go ahead and multiply this over. This is going to be 10x minus 15y equals negative 100. This is going to be 9x plus 15y equals 81. Add these up, and you get 19x equals negative 19. Divide off the 19, divide off the 19, you get x equals negative 1. Okay? On the paper, I chose to the second equation, so this time I'll do the first. Okay? I choose first equation. Okay? So, 2 times negative 1 minus 3y equals negative 20. That gives me negative 2 minus 3y equals negative 20. Add your 2. Negative 3y equals negative 18. Divide off the negative 3, divide off the negative 3. Y is positive 6. So x equals negative 1, y equals 6. Negative 1, 6 in order pair notation. Okay? The reason why people might do different things is some people like to cancel out the variable that's farthest from the equal sign. Some people like variables that like situations where the signs are already opposites. Okay? It really is all up to what you prefer at any given time. So let me get this off the board. We do example 2. I'll do another example, and then we'll do example 3, and then I'll call this done. Example 3 for elimination. we have 3x plus 4y equals 14, and x minus 6y equals negative 32. Okay? If I was to choose to eliminate, I would choose to eliminate x. Okay? I choose to eliminate x. The reason I choose to eliminate x is because the lowest number, the 3 and 1 divide evenly is 3. So I would only need to do one multiplication. I need 3x and minus 3x, or negative 3x and 3x. Okay, I need either one of them. Okay, I've already got 3x, so I'll choose this one. My choice. So I would leave the first alone, leave first equation alone, and I'd multiply this one by negative 3. Okay, so this is going to be 3x plus 4y equals 14. This is going to be negative 3x plus 18y equals positive 96. So 22y equals 110 again. Divide out the 22. And y equals 5. Okay? So I don't really care which equation I use. I suppose I'd actually plug it into this one because the x coefficient is 1. Okay? I choose x minus 6y equals negative 32. Okay, so I got x minus 6 times 5. Okay, equals a negative 32. X minus 30 equals negative 32. Add your 30. And x equals negative 2. So x equals negative 2. Y equals 1. Okay? Do you remember that in an ordered pair, the variable solutions need to be in alphabetical order? Okay? And that's it. That's all I have for this. You guys can look at the other example if you wish on the paper.